So let's kick off then. So thank you for coming. This is a many model forecasting in real time. So I present myself quickly. I'm Anastasia, so I'm part of specialist team at Databricks. I've been at Databricks for the past 3 years. I'm a global SME and also a product champion for model serving. So that's going to be covered today mainly for the talk. So today we're going to talk about how to actually implement in a scalable way forecasting on Databricks, and also how can you bring those models in real time. We're not going to cover how to make a good forecasting. So sorry for that. If you want to know more about forecasting, I'm happy to chat with you later, okay? So what are the main sort of setup for today that you need to keep in mind? Usually when we work on forecasting, we would distinguish sort of two types of models, okay? The global model forecasting and then the local one. The main difference is that the global models usually considering many time series together, all right? So we would kind of consider them collectively and create just a single model that we call global forecast. Versus the local models, that actually permits us to have more granularity level for forecasting, and hence actually to scale this and to improve the quality, especially, for example, for sales forecasts. So today I'm going to show you and actually walk you through how can you scale local model forecasting using Databricks. First of all, I just kind of bring you to a setup that you all kind of think of you as you're a retailer, okay? And you're trying to actually create forecasts of hundreds of thousands of models, right? So you want to have a granular forecast, and your key issues are that training takes a lot of time, and that you're not sure how to actually bring this in real time. Because usually when we talk about forecasting, we do it in batch fashion or sometimes streaming. But how can you actually bring this whenever, for example, a stock manager and I'm requiring to verify the latest demand with all the features that I have, like weather, promotions, maybe marketing campaigns, how can I actually bring this in real time, right? On top of this, you want to actually standardize on code. And so you want to have everything governed and, like basically MLOps standards. So the architecture that I've been presenting to my customers that have been working across years look the following one. Of course, you start with the data, all right? So you do data pre-processing, and then you do a pre-training, and then somehow you actually need to serve it. So today I'm going to actually show you this part, okay? So how can we actually ingest data into features that can be later joined in real time to our models? How can we actually train models? How can we actually scale hundreds of thousand models? And how can we bring those models in real time, but not sacrificing actually the capacity or capability of doing it batch or streaming if necessary, all right? So in order to do that, we're going to use the main tools, but also new tools of Databricks. So first of all, we're going to use MLflow, Delta, and Spark as native features. On top of this, today we're actually going to learn and meet what is actually hosted model serving on Databricks, what is feature store client, and what is actually online tables and feature serving, all right? So first of all, let's start from training. We need to create our data set. So data set on Databricks can be simply created by actually ingesting your data in the Delta table. Recently, Databricks announced a new feature store client called Feature Engineering with Unity Catalog. This is actually a Python SDK that helps you to create and construct a metadata that can later be actually used by creating direct acyclic graph for any model that you actually using on Databricks, whether it's batch or streaming or real time. So how it works? In reality, whenever you already have a Delta table, it's very simple. You just actually need to set a constraint on a primary key. Once this constraint is set, our technology will understand under the hood that this is actually a feature store table, and you can start creating what we call lookups. The goal of a lookup is, for example, if you have a huge table, but you just want to play with certain features, and in reality, you want to compare, for example, models for different features. As you see here, I'm just using a few features through different tables. For example, here, I actually have two feature tables. I have a table that contains school holiday and promo, and in another table, I'm going to use only mean temperature in Celsius. Once I choose my features, I just create a training set. This is actually a metadata that's going to be serialized and put under the hood on the platform. So now let's talk about training. Sorry, there is a lot of code, but I promise I will send you a link later so that you can actually verify. I just wanted to briefly explain you what are the quickest win for you to scale your individual forecasting models. It's actually by using Spark and using the technology that we call applying pandas. Applying pandas helps you to apply any Python code and actually serialize it using Spark. The main sort of trick and the way that we recommend using it today, it's actually not storing your model physically under MLflow. You can, of course, track any parameters, you can still store them. But the trick that really helps you to accelerate so many models and put them later in production is by actually serializing the model inside the training. Once it's trained, you just serialize it and you actually store it as a delta table, all right? And to do so, you just simply return it as a string by encoded any pickle model. Of course, this is applied mainly to forecasting. We're not gonna recommend you to do this for LLMs simply because they're huge, okay? So this is use case purely for normal local models that we all do for machine learning. You can also still use MLflow. The trick of using MLflow is simply by actually doing what we call a nested run. So you actually start a global run first before actually evoking a group by on your unique ID. So here I had thousands of stores, but you can also provide horizon. You can really group by over dozens of keys, okay? So it can be store, it can be state, it can be horizon. It depends really on your use case. Once it's done here, you can actually create a nested run. So this is actually going to track any parameter that you want, but later they're going to be actually associated to the global one, right? So once it's done, what you're actually going to get, it's a serialized model per unique store. First of all, you can add the training data, you can add a versioning, you can also add a real tracking model URI, you can add anything to this delta table because they're all versioned. You can always go back and roll back and you know all your history. And once you do not need them, you can simply delete the version of unnecessary table, all right? So once this is done, how can I actually now bring all of this together, right? Because as you may guess, we will have hundreds of those models. And this is not what I want, right? I want to somehow bring them all in real time. The problem usually that people face is that whenever you have hundreds of models or thousands of models, people think, oh, I need to serve them individually. And this is actually very expensive. In reality, the first way that you can do is just to package them all and actually serve them on the model serving container of Databricks. So the basic way of packaging anything under the container of Databricks is actually placing anything in the memory of the container. To do so on Databricks, you're required to use what we call load context under what we call a customized ML Python, right? So whatever you want to bring into memory of your container, this is the way Databricks container service works, has to be placed under the load context. So there is a small gotcha because actually container has a certain size, right? So say if you have millions of models, it can actually exceed the container size. Hence, it's sometimes not the most scalable solution. On the other hand, I also use this solution with customers to actually bring multiple computer vision models because sometimes our models are pretty tiny and we're requiring to serve maybe 5 or 10 models at the same time. So load context, it's very simple. So now actually let's see how can we combine the data in real time to the model. So as you see here, I'm loading the model, but I'm loading the model using feature engineering client, okay? So once we actually put the model, we put all our artifacts that's going to be brought to the container, we bring in this training set that's we've been using for training as it's a delta table. This is going to create an additional metadata that's actually going to learn which type of feature has to be joined, okay? So this can be used in batch, in streaming, and in real time. The goal is that whenever something is evoked on an ID of a store, it's going to go look for these features. If features are provided, it's going to be joined before actually looking for them. So the system actually is very smart. It's going to look for a schema match. If the schema is matched from what you provided, it's not going to call anything from the feature store. So how can we actually now do it in real time? In real time, we need to join our features like basically, with milliseconds latency. So there are two options how you can do it. So first of all, you can actually publish all your features into what we call online tables. So online tables, it's a new feature that's I think now even GA. It's literally connecting to your original delta table. So there's really not much to do. You just need to publish it online. Once this is published and you're going to evoke a model serving container of Databricks, again, the service is going to automatically go and look for those features. You don't even have to pass them yourself. And again, if you're passing them, then the service first taking the features that you're passing and only then checking for missing features to be joined in the real time. On top of this, what you need to know is that those tables are actually capable to also do a time lookup, meaning whenever you pass in fresh features, it will only go and take the freshest features. So you can also actually enhance those kind of feature freshness by simply adding a timestamp key on top of these online tables. So this was the first version if you pass in actually all models to the container. There is a second model, there's a second version how you can actually pass those models. And this is actually probably my preferred one, simply because you almost don't have to do any code. And second, it's actually scalable to trillions of models because you are going to publish your models as a feature. So instead of us creating a container with all of these models in a memory, we're just going to actually publish them as a Delta table in real time. First of all, it gives you access to bring those models even outside of Databricks model serving, because we also let you to do this as a feature serving, meaning I'm just publishing this spec, I'm calling an ID, and anyone can get object of a model or any feature that I'm using. And again, on our service, you don't even have to do anything. It's going to call automatically. So now let's go see actually how it would look when you serve a feature. So here, actually, I'm asking for a store number 1. And as you see, I'm getting all my models that serialized outside. So this is not a requirement. I just wanted to show you that this exists, and it's because I served this spec. So this spec, again, it connects to all my models here. So in reality, I could join all the tables together and just simply basically serve all of them together, okay? It doesn't have to be like one table. You can join multiple. It's called a spec. And then we serve in this spec in real time. This can be accessed outside as it's a REST API. You don't even have to use Databricks model serving. So it's a very unique option. But say if you're using actually Databricks model serving and you simply want to join your tables, how the code going to change versus us publishing everything to an artifact versus us actually calling models as a feature? In reality, you just need to change a lookup. So now on top of features in a lookup, I'm also adding actually lookup to the models. And then later, I do not have anymore any load context because I do not have to load anything in memory. I simply call my models when they join with my main ID to actually inside the predict function. So it's going to be called in a millisecond latency, join with all the data sets that are required, and actually make a prediction. The beauty of this method is that whenever you actually want to update the model, you do not have to change your container anymore, because as you may guess, with the previous version, when we actually published everything to container, whenever I want to re-update it, I actually have to republish everything to container. In this way, we just need to actually push a fresh data, so fresh models on a, again, timestamp key, and it's going to be automatically updated, okay? So you don't have to actually do anything anymore. So once this is done, actually, you're just ready to serve, okay? So here again, everything is under the Unity catalog. So you see, I've actually created multiple models that work exactly the same way, okay? So whenever you're publishing all the models into a container, whether you're calling them through actually a REST API as a feature serving publishing, or whether you're just calling them as a feature through an online table through model serving of Databricks. So here again, I'm asking, please predict me for store 1. And as you see, I'm getting all the predictions by serving the latest version of my model. So now the conclusions before we come to the questions. Something that I wanted to tell you is that actually this is not just for the forecasting. You can use it for recommender system, for GenAI agents. An example for a GenAI agent, it's especially useful when you want to join some tabular data, okay? As those features are published online, it's a low latency lookup. Whenever you actually need to bring anything, can be your prompt, can be your template, can be anything. So the feature online is a very useful and again, scalable solution. Then second, using distributed training and again, online store for bringing a simple features as your models, again, enhance your capability around the MLOps, around feature joins and everything. So whenever new features come in, you're ready to go. You don't have to do any manual job. All this script that's been shown, again, capable of being run batch and streaming in real time. So you don't have to redo all the job every time. Once the code is done, the feature is going to be joined or batch or real time, depending on your use case. So the script will be available by the end of the day on this link. So we didn't publish it yet, but it's going to be available. And there's going to be also blog post part 2 coming around the online store. So if you want to check the script, that's going to be here. Well, thank you then very much. If you have more questions, we can take it then outside. Thank you.